Right, so the job has not been completed, but I noticed something in the file here. Uh, it it's just disrupted because I stopped it, and I did obtain some um, failure modes. Those are visible over here, and these are the jobs files here. So let me open the Abacus viewer, right, and work on some of the files such as the results and do some visualizations module techniques to understand what's going on in the model. And let's go to the failure mode, just open them to look at them, what's going on here. So these are the one mice stresses. This is the one failure mode and compression. This is for the tension failure mode, and we have this fiber over here, and these are the compression status results. So yeah, let me open the testing job that we submitted in the previous video, and let's check it out here and go to option and common. But before that, I need to go to the graphics option and make it white. Okay, and go to view, and over here go to view, and ODB display option. Sorry, view for edit annotations, show alarm, show legends only, and yeah. So if I switch on this view, I can see here, and in the option in common and free features, the fibers are visible here. You can see the stresses, etc. Um, those are visible in the fiber, and the stress concentration is visible here. So the axial stresses are shown here. So let's just remove the um, part instances that's here. This one too, and this one too, right? So you can see here that these are the stresses in the fibers, and some are compressive in nature, some are tensile in nature. And if you remember in the previous video, I did a discussion on the aligned fibers. So now at this location, if I look at here and I just change the frames here, those traces, those fibers, those are contributing. At first, the compressio all are in compressio nature, but then the nature of the um fibers by taking stress is changing here. Compression force is converting into tensile force. You can see here, and how those tensile force are laminating over here. And even if I check the S11 direction here, I can see here. So these are the forces that I was talking about, that how these fibers are helping us in transferring those stresses over here, right? So yeah, these are something that we are interested in. And if I go to option and common and keep it like this, however make it non-uniform, then I can do make it a non-uniform as well. And let's go to active yielding here, switch it off, sorry, switch the transparent view up, and go to any view here, then switch it on back, and sorry, switch it off, and then you can see how that is helping us in visualization module. Intention failure, sorry, compression failure. It is completely failing in compression. While intention, the fibers are oriented in such a manner that in tension, the crack appear in this way. So we can visualize it further by changing its limits here. So if we make it 0.01, something like that, then you can see here that how it's failing here, right? Then after that we have the plastic strain and equivalent plastic strain. That is another type of visualization technique that we can use here. And we have stresses as well. But for stresses, we need to make sure that since the cylinder is 61 MPa, so if I consider 25 MPa, I am able to check the stresses over here as well. Now I have to extract the results from it. So if you remember, I defined these in the previous uh, file using the field output request and history output request. So if you look into the history output request here in the input file, we can check them as well as I can open the abacus file, FRC2, and let's just go back, look at the status file over here, and I was talking about where was it? In the output request, always try to use restart analysis just in case if the analysis disrupted, then you will be able to get it. Yeah. So these are the lines here. These few lines are showing the forces history output request and displacement history output request. This is responsible for the reaction force, and this is responsible for the displacement over here. And this is defined here in the field output request. Anyways, let's make it. I did these changes here, so let's make it like this. Go to interaction and not in interaction, but in the step. I mentioned these that I have defined these U2 here for the top RP, which you can see over here. This is for the top RP, and similarly we have this one for the base RP. So this is for the base RP. It's visible here, and let's go to the visualization module. Click on continue and save them as reaction force, right? And save it as a displacement, right? So let's go to operate on XY data, then go to combine, um, sorry, combine displacement and reaction force dot expression. We need to check the direction, so let's go to make it negative, just to change the direction only. and we have this much amount of force here. It is in Newton, so I need to convert it to kilonewton. So if I plot this expression, you can see here it is in kilonewton. Now if I want to find out the stress versus strain, so I can make something more like this. Displacement divided by total height. So let's go to tools, query, and distance, and find out the total height, that is 300. So uh, this is now strain, right? And if I convert it force kilonewton per square meter, if I convert it to Newton per meter square, divided by cross section area. So the cross section area, we can find out the cross section area in an easiest way here, like this. If I go to mesh and separate this here, instances, and then go to tools and query. No, I go to tools, query, and geometric diagnostic, not geometric diagnostic, but mesh. Okay, but why we are not able to get any mesh here? Control T. Let's go to which model I mean. File, open. Yeah, this one. Let's see what's going on in the model. Okay, let's just mesh it. It was already meshed previously. And I remember the sheet size. Okay, so let's just separate it and then go to tools, query, and mesh. Yeah, mesh over here, and there was a feature. I don't remember that. And then, so area of selected face 17 671.76. Let's copy it and paste it over here. So it's and let's just remove this here as well. So it is strain versus stress, and we can find out the cross section area here as well. So it is 5 3.14 d square by 4, 150 steric 150 divided by 4. So 17662, and here 17671. Because of the mission, it's changed here. Look at here, something like this. It's this much, and this 150 by 150 is d square, and d is 150 because it's the dia. And if I plot it here, it is strain and it is stress. So let's just do it like this. Go to instead of displacement, uh, let's call it stress, and stress will be Newton per mm square, right? And displacement is basically strain mm for mm, right? So yeah, that's it. And now let's take a screenshot from it just to save it here. It is in this, and we can call it stress strain curve, right? So remember I mentioned these three things over here. This one up to this region it was before cracking, then it was cracking, and this region it was elastic. At this point the crack and damage occurred, while in this point it is strain hardening. So go back to the previous videos, you will find out the discussions that I did. And let's go to tools, plugin tools, Excel utilities, and let's just take this from the current plot. I will stop this recording.